In this lesson, we will cover the application of the formula for the general term of a binomial expansion. The general term for the binomial expansion a plus b to the power of n is given by term r plus 1 equals to nr multiplied by a to the power of n minus r and b to the power of r, where n refers to the power of the term in the binomial expansion, a refers to the first term in the binomial expansion, and b the second term in the binomial expansion. The formula for the general term of a binomial expansion is used to solve questions where we are asked to find the coefficient of a specific term. For example, the term x to the power of 7 or x to the power of 12 or x to the power of -5 or the constant term. As we do not know the specific positions of this term in the binomial expansion, we need to use the formula for the general term of a binomial expansion to solve such questions. Here's an example. Find the coefficient of the x6 term in the binomial expansion 3x squared over 2 plus 2 over 3x to the power of 9. We first state the general term of a binomial expansion formula, and in this question, a, the first term, refers to 3x squared over 2, and for simplicity we always write it as 3 over 2 x squared. The second term, b, equals to 2 upon 3x, and again for simplicity of our manipulation later, we always write it as 2 over 3 times x to the power of -1. And in this question, n is 9. Now, we can substitute all these terms pertaining to this specific question into the general term formula. So we have term r plus 1 equals to 9r 3 over 2x squared to the power of 9 minus r, and 2 over 3 x to the power of -1 to the power of r. In the next step, we will want to split 3 over 2x squared to the power of 9 minus r into 3 over 2 to the power of 9 minus r and x squared to the power of 9 minus r. Similarly, for the second term, we want to split 2 over 3 x to the power of -1 into 2 over 3 to the power of r and x minus 1 to the power of r. In the next step, we then rearrange and put all the coefficient terms together. So we bring this 2 over 3 to the power of r to the front here, and we group the two x term together. So x squared to the power of 9 minus r, we put it behind together with the term x minus 1 to the power of r. And in the next step, we will simplify x squared to the power of 9 minus r into x to the power of 18 minus 2r. And in the final step, we can further simplify x to the power of 18 minus 2r multiplied by x to the power of -r would be x to the power of 18 minus 3r. And remember, in this question, we are asked for the coefficient of the x to the power of 6 terms. Therefore, what we want to do is to equate this power 18 minus 3r to 6. And we can then solve very simply. R equals to 4. So we know that this term x to the power of 6 is actually the fifth term. Remember, r equals to 4, therefore it is the fifth term. And the coefficient of the x to the power of 6 term can be found simply by substituting r equals to 4 into this expression over here, and hence we have 9, 4, 3 over 2 to the power of 9 minus 4, and 2/3 to the power of 4. And that will simplify to 189. Hence, the coefficient of the x to the power of 6 term in this binomial expansion would be 189. One further variation of such a question could be to ask you if a expansion has a particular term, for example, x to the power of 7. In which case, what we do is every step is exactly the same, except that in this step here, we will equate 18 minus 3r to, let's say, if they ask you if there is such a term x to the power of 7. So you equate that to 7, 18 minus 3r equals 7. If you find that r is not the whole number, it's not the integer, then the conclusion is that this expansion does not have a term where the power of the x term is 7. And this is how you can apply this formula to prove if a binomial expansion contains a particular term.